Okay, so now we have to write domain and range for fractional function. Then we will move to 1 on to that call. Okay, so domain and then the range. Okay, see here you can give any real numbers. There is no problem with that. As an input, you can give any real numbers. Okay, I will just write just R. Then coming to the case of range, if you just check it out, I said that it should be only positive. Okay, so that means you will be very much clear that it will be absolutely above than y-axis. And also fractional part only you are considering. For an example, you take 4.7, then for this 4 plus 0.7, so here the answer is 0.7. When you take 3.2, here the answer is 0.2. So for any fraction that you are taking, okay, so for any numbers you are taking, for that it is going to lie between 0 to 1 only. Okay, it is going to lie between 0 to 1. Okay, 0 is included, 0 is included and 1 is excluded. Okay, so this is for fractional part. Okay, so now at last, within victory, we have completed this. So, okay, see, we will do one sum, that is f of x is equal to signum of 9 minus 7 sin x. Okay, correct, right? So here, what is the domain that you can give inside? For signum function, you can give any number as domain, right? So that means domain is equal to, for this, domain belongs to all real numbers. Even take here x, there is x. For sine theta, you can give any number as domain. Okay, that means as an input, but the output will be lying between 0, 1, sorry, from -1 to +1. Okay, then coming to here, now what you have to do is, since your domain, what they are asking is, they are asking you the range. Okay, they are asking you the range. Okay, so first you have to take only the sine theta. Okay, see, sine theta will be lying between, okay, this is what it is. So what you have to do is, see, you have to multiply with you have to multiply it with 7, and then you have to also, yeah, -7, you have to multiply that, and then you have to add 9 to it. Okay, so first multiplying it with -7. Okay, so when you're multiplying it with the -7, what will happen? This sign will be changed like this. Okay, so here it will be plus 7. Okay, so here it will be -7 sine x. Like this it would have changed, and here will be -7. Then what else you have to do? You have to add it with 9. Okay, so adding it with 9. Okay, so when you add it, so this would have turned into 16. Yes, now, so here it will be 9 minus 7 sine x. Then here it will be 2. Yes, now. Okay, so here it is 2. So 16 to 2. So this is actually going to be 16 to 2. That means this input, okay, see, this total value we are talking about. So 9 minus 7 sine x. No matter what input you give as x, the total input, that means this total value will be lying between 16 to 2 only, it will be lying. So which means what? Okay, which means what? It is a positive number. 16 to 2, it is actually a positive number, right? So when you are giving a positive number as an input for this signum function, then automatically it will be turned into 1. So the range is going to be what? 1 only. Okay, so the range is 1. 1 second. Yes, answer is correct. The range is 1. Okay. So I hope you all would have got some idea how to do these sums. Okay. Actually, I've also taken a screenshot of answer so that I will not make anything wrongly. I will not write anything wrong. Do we have another question? Okay, so we do have some other questions. We will do one by one. Okay, we will do some questions. Okay, I also have answers. Okay, so first is we are going to do for this question, which is f of x. Okay, f of x is equal to, very easy questions these are. We will do one by one and you will be very much comfortable with them. Okay, so I hope the question is clear. Okay, f of x is equal to root over x square minus 5x plus 6. Okay, so this is what the question is. So now how will you answer this? First you have to know that any input you have to, okay, this inside value, okay, this inside value should be always greater than 0. That is a rule for root. Okay, for root it has to be always greater than 0. So x square minus 5x plus 6 should be greater than what? It should be greater than 0. Okay, so you can factorize it. So it will be 6 then minus 5, so minus 1. Wait, how can you factorize? 2 and 3, yeah, sorry, minus 2 and then minus 3. Okay, so minus 2 and minus 3, when you are multiplying it, you will be getting 6, and when you are adding it, you will be getting minus 5. Okay, so now I'm going to do this. So then it will be x square minus 2x minus 3x plus 6 is greater than 0. And here you can take common. Okay, so what can you take here? Common. X you can take common. So x minus 2 here will be minus 3, you take it as common. Okay, so then it will be here also x minus 2. These two should be always same. Actually, when I was studying in 7th standard, I did not know how to do. And I was in online class. So my sir asked me, Kannan, answer this, how to do. And I was like, I did not know anything. I was like, sir. Then I learned it. Okay. Since it was online class, I have never paid attention to any of the classes. 7th and 8th. Okay. So coming to here, how can you take it as x minus 2 and then x minus 3 is greater than 0. So you have got this right. Now, you will use Verbico method. Okay, so what are they? You have got x is equal to 2 and you have got x is equal to 3. Now we will do the wave. Okay, so it is actually greater than. Greater than in sense you have to take only positive region. Okay, so positive region and this region you have to take and this region you have to take. So at last the answer is going to be so x belongs to what? Minus infinite to 2. Okay, minus infinite to 2. Make sure everything is open bracket and union with 3 comma infinite, and I check the answer. Answer is correct. Okay. And also one thing you have to note, that is here this can be equal to 0. Okay, this can be equal to 0. There is no problem with that being equal to 0. Okay, so that means equal to. So which means that here there should be close bracket. Here there should be close bracket because root over 0 is 0 only. There is no problem with that. Root over 1 is also 1 only. Okay, so you have completed this. I will write here in the next question also. Okay, so next question is, wait, that question completed, this question completed. Okay, so next is a different question. Okay, this is actually kind of a different question, which is f of x. Here you have to know one concept that I will be saying to you. So f of x is equal to 1 by root over, okay, x square minus 3x plus 2. Okay, so plus 1 by root over, sorry, wait. I've written the question wrongly. So f of x, song is amazing, right? There is a singer nearby my home. Okay, is equal to root over x square minus 3x plus 2 plus 1 by root over, sorry, 1 by, yeah, root over x square minus 3x plus minus 4. Okay, minus 4. So what you have to do, see, here one is in the numerator, here one is in the denominator, and there is addition. So what you will be doing here, the thing is, in order to take, see, in every place what you have found, okay, you are finding the domain only. Okay, so you are finding the domain. If it is x, then it is domain. If it is in terms of y, only it is range. In every terms, everywhere you have find only. Here you have found the range. Here you have found the domain. Here also they are asking you to find the domain only. Okay, so how will you do this? Like this. Okay, see, if one function is there. Okay, if one function is there, f of x is there, and inside that there is another function, and also there is another function that is being added to here. Okay, if it is like this, then what you have to take is, what you have to do is, you have to find domain of this function, and then you have to union it with this one. Okay, then you have to do union with this function. Okay, then you will be, sorry, intersection, not union. Okay, intersection you have to do. That means you have to take the common point of this and common point of this, then you have to add them. That is what your domain will be. Okay, don't do union. Union itself will be completely wrong. You have to take intersection. That means common point from this and common point from this, that you have to take and write. Okay, ma. So already we have done, we have seen how to do this, but it doesn't mean that I'm not going to do. I will be doing now. Okay, so root over x square minus 3x plus 2, which is going to be absolutely greater than 0. So this value will be greater than 0 and also equal to 0. Okay, so how will you factorize this? So it will be like, when you add it is 2 and minus 3, so it is going to be minus 2 and minus 1. Yes, now. Okay, so then x square minus 2x minus x plus 2, okay, is greater than or equal to 0. I will rewrite it as minus x minus 2x plus 2. Okay, plus 2 is greater than or equal to 0. Now take x as common, so x minus 1, and take minus 2 as common. So when you're taking minus 2 as common, then it will be x minus 1. Okay, it's greater than or equal to 0. So when you can write it as like this. Okay, so now you can do the wavy curve method. So plus 2 plus 1, then okay, here it is greater than, so take plus region, and here it should be this bubble, here also this should be this bubble. That means it is dark bubble. Okay, so the answer for this is going to be all this region and all that region. Okay, so these two regions it's going to be, and when you are writing it in terms of domain, so you can write it as minus infinite comma 2 into no, here you have to take union. Okay, here you have to take union with then 1 comma infinite. Okay, so this is what your answer for this one part. Okay, and the answer is, oh, what have I written there? Here now 1 should come, and here only now 2 should come. Here 1, here 2. So which means you have to change this. Okay, now it's correct. Okay, now it's correct. I'm so sorry. Where am I? Okay, so this is for this part we have found. So I will erase this. This is okay. Then okay. Now, so this is for D1. Coming to D2. How will it be for D2? Sorry, like f of x2. Okay. So you have to take this blue color. So you have to take this. See, remember, here it will be actually x square minus 3x minus, what is this, 4, huh? Right? Even I don't know what have I written. Yeah, 4, okay. Minus 4 should be greater than or equal to 0. This we have seen, right, since it is in the root. But since it is also in the denominator, see, here it is in the denominator. If you put, okay, in place of this, if you put here 0, then what it will be? It will be 1 by 0, which is equal to infinite. Okay, so that is not allowed it. So what you have to do is you have to take this 0 out. Okay, so take this equal to symbol. Now you have to do, so which means, okay, when you're writing, you're not supposed to put closed brackets. You're supposed to put only open brackets. Okay, so here it is, minus 4. Here it is minus 4, then the minus, then you will be having minus 3. So when you multiply, okay, so minus 4 and 1 you will be getting. Okay, so when you multiply, you'll be getting minus 4, and when you're adding, you'll be getting minus 3. So x square minus 4x, no, I will write here just plus x, okay, plus x minus 4x minus 4. Okay, so take here x as common, so here will be x plus 1. Okay, x plus 1. Here minus 4, if you are taking none, then it will be x plus 1 only. Greater than 0. Okay, so now factorize it, then it will be x plus 1, then it will be x minus 4. Okay, then coming to shapes, then this one. If you notice, here one number will be, here it will be minus 1, here it will be plus 4. Huh? Okay, so draw this. Okay, so when you are drawing this, correct. Okay, plus minus, sorry, plus minus. Wavy curve method is very, very important. Okay, wavy curve method, that is what you have studied in class 11th itself, is there, right? That is very, very, very important. You have to know that. Don't worry, even if you have not paid attention in your class, then there are videos in YouTube which is in English where they are teaching you wavy curve method in a very in detailed way itself. In detailed way. That means in a detailed way. Okay, so then here it will be minus infinite comma minus 1 open bracket union with plus 4 comma infinite for everything open bracket. For everything open bracket. Okay, that is something. Oh, I have to know. Okay, next is D1 intersection with D2. For this, what we are going to do is take a number line. Within this one number line, we are going to end this sum itself. Okay, so what all you got? You got 1, 2. Okay, you have got 1, 2. So 1 you got, 2 you got, 4 also you got, then minus 1 also is there, right? So minus 1 also is there. So minus 1 you got. So for this at all, wait, for minus 1, where it is? For minus 1 from infinite, from minus infinite to minus 1. Okay, so that means like this. Okay, make sure that it is open bubble. Then for 1, where it is? Okay, for 1 it is closed and it is from minus infinite to 1 only. So that means, okay, so like this it is. Okay, so coming to here, which is 2 comma 4. Okay, so for 2, where it is? For 2 it is closed and from 2 to it is plus infinite. Yes, right. Then for 4, open to here. We will check one thing. Yeah, closed. Okay, correct. So what is the common area? Is this the common area? No. Is this the common area? No. Is this the common area? No. This is what the common area is. It is not common area. It is common area. Okay, common area. Even I was feeling like I'm saying common area. Common area. Okay, so you've got this region and you've got this region. Okay. Now, how will you write that? You have to take intersection. Actually, if you're feeling kind of trouble with this, okay, what you have to do is, I will say, so minus infinite comma minus 1 union with what? With 4 na? With 4 comma infinite. Intersection you put. Okay, then you write this one, which is minus infinite comma 1. Okay, union with 2 comma, correct. Correct. Okay, so 2 comma infinite. Like this also you can write. Okay, where this is actually that f of x2, this is actually this is f of x1 and this is f of x2 is a domain. That is what you have calculated. Like this also you can write, or You just see the common area, then you take that one. So then it will be minus infinite comma minus 1 intersection with intersection or union. Union. Yeah, here it should be union. Then 4 comma plus infinite. Okay. See, I will say y intersection, y here union, y here open bracket. First of all, yeah, you have taken this area, and when you are seeing this, this is actually what open bubble. So you have to take here open bracket. Here also you have to take open bracket only. Then coming to the case of intersection, already I have taken the intersection. This intersection and this intersection you have taken. Actually, what you have done, this part and then this part you have taken, and their intersection only you have written here. Okay, this part and this area you have taken, and you have written that's intersection. Here also have taken this ones and that intersection we have written. So here when you are taking these two, see here union, already have done intersection, already intersection has got completed, we have already done here, and that is what you have written, and you can see union is what they, so you have to write union. That is a way how I can say. Okay, so then the answer for this question is, that is what I've written in blue color, but I'm not satisfied with that color. So then the answer for this question is minus infinite. Oh, this is white. Okay. So minus infinite comma minus 1 union with 4 comma plus infinite. Okay, so you have got it is like eyebrows. Okay, so then what do you have? We have lots of sums. Okay, so we have rational functions also, but since we are mainly concentrating on board examination, not on JEE examination, so we are not going to look at them. Rational functions, but I cannot leave them also just like that. Okay, it won't be correct. Okay, then I'll make a separate video for this rational function, since it is a very big topic. Okay, rational function is not a small topic. And also I have some shortcuts, very easy shortcuts. Like if you're seeing within this much time, you can easily do answers for everything, just within seconds for linear rational function. Okay, when you're taking like that, for that at all, I have very amazing shortcut tricks. So we will do that one later. Then next part that we are going to do is many one. We have at last entered into one of the most important part. And I cannot start here. Here only I have to start. Okay. So very important part, that is okay. That is types of functions. In that we have come to categorize them. Okay, see this is very important. Proof we have to do, lot of things we have to do. So please we have to be very careful here because it is kind of the tricky part. 4 I have to get. 5 is there. 5 or 4? 3. Wait. We will say. I will say. So it is types of functions. Okay. So types of functions. See, first we will be discussing about 1. Oh, why it is not hitting? 1. Okay, 1 function. Then we will be discussing about onto. Okay, here we will be discussing about many one. Okay. Okay, many one we will be discussing. Then also into you will be discussing. Okay, so into you will be discussing. Then many one into 1. That's it. Okay, only these many are there. We will be discussing. I thought I should not leave anything, right? Okay, so that's going to be. Okay, so first we will be discussing one by one. And there is no problem with it. Okay, so first is 1 function. What is this 1 function? 1 function is actually you have to take this domain. Okay, see, you have got some elements here like A, B, C, D, E, and then F. And here you have got like 1, 2, 3, 4, 5, 6, and then 7 you have got. Okay, so like this you have got. Now, what you are doing is, see, every domain, okay, one domain should be connected to only one range. That means one element from the domain has to be connected to or should be mapped to one element from the codomain. Okay, so like this it should be. See, it should be mapped like this. Okay, and it's okay to leave one element from the codomain. Okay, it's okay to leave one element from the codomain, but don't make that mistake by leaving one element from the domain. Then it will not be function itself. Okay, then it will not be a function itself. You are not supposed to leave any one element also from the domain. That is what we have seen in the beginning itself, right? They have written 3 laws. So amongst them, this is also one law. Okay, so don't forget that. Okay, so you're supposed, you can leave. There is no condition like you should leave or you should not leave. There is no such condition. You can leave. If you want to leave, if you don't want, then map it also. But don't map it like this. You are not supposed to map it like this. Okay, this is also not correct. Okay, this is also not a function. And also, you are not supposed to map it like this. Wait. Okay, like this also you are not supposed to map. Okay, this is also not a way. That means, wait. That means GH. So like this you are not supposed to map. Like this also you are not supposed to map. This should be having only one pre-image. Okay, this is not correct. Okay, this is not correct. Okay, so this is a domain. This is codomain, and this is actually here you can see which is not equal to range. Note this one point. This is not equal to range. Okay, all these are what? All these are pre-images. Okay, here you are having images. Okay, so you have got pre-image, you have got image, and these are some points, and you can see this one point, that is, I will be not this one point, this is the definition I'm going to write. Okay, like a trick also you can say, every image should have only one pre-image. Only one pre-image. Okay, so I've got like this. Then is there any other thing? That's it. Okay, it's like, see, you're shooting from this tishko. Okay, so like you're just shooting like this, and you can see only one police or one military person or one squad should be actually attacking only one terrorist. Okay, 1v1. Okay, even in WWE, that is what the name now for that fighting thing. Okay, so even there also, if you check, their opponents will be equal in weight ratio. Okay, it will be kind of similar in weight, and also their size also should be similar, because you cannot leave a 35 years old man to fight with a 10 years old boy, right? Okay, that's not allowed enough. So like that, it's like this. Okay, this is actually like with justice. Okay, but many one is not like this. Okay, exactly opposite to one is many one. Okay, so since it is completely opposite, I'm going to write it here itself. Next is many one. What is this many one? You have got domain, then the codomain. Okay, here also, wait. I'll first write it, then we will check about the range at all. So, and then give here A, B, C, D, E, F. Here I will give it like, no, wait. 1, 2, 3, 4, 5. Wait, I will first draw and see whether it is correct or not. Okay. Okay, so when you check here, this is pre-image. This is pre-image and then this is image. When you check here, okay, let us take this one. Okay, then let us take this one. Okay, that is when you take this one, you can see that this one image is having two pre-images. So the definition of this function is that, okay, the definition of this function is an image should have at least one pre-image. Okay, an image should have, sorry, that will not be correct grammar. Okay, at least one image should have more than one pre-image. Okay, this is correct. At least one image should have more than one pre-image. Okay, and also here I've said, right, here it is not equal. Okay, it is not a condition like codomain should not be equal to range. It is not like always codomain should not be equal to range. Sometimes, okay, it's okay. You can write like codomain can be equal to range. That's not a problem. Okay, it can be equal or it need not to be equal. Okay, that's it. It can be equal or it need not to be equal. That's okay. Okay, here also same thing only. It can be equal or it need not to be equal. To range. Okay, so if you want some examples, okay to give you some examples. What are those examples? Which color? Oh god, I'm hungry. So root over x we can say. Okay, modulus x will not come. Okay, make sure that you are not writing that one. Y is equal to x. 1 plus x. 1 plus x will not come. Okay, modulus x will not come. Okay, modulus x will not come. Okay, y is equal to x. 1 plus x. 1 plus x will not come. Okay, modulus x will not come. Okay, modulus x will not come. Okay, modulus x will not come. Okay, y is equal to x. Okay, modulus x, will it come? Here only modulus x will be coming. Why? For both -1 and +1, the value will be +1 only. Okay, +1 only. But if you restrict the domain from 0 to 1, okay, sorry, from 0 to infinite, then modulus 1 will be, then modulus x will be a function. Okay, what function? Then it will be many one function. Okay, then it will be a then it will be one function. Sorry. When you restrict it, when you don't restrict it, here only modulus 1 will be coming. Okay, sorry, not modulus 1, modulus x. That is modulus x. Okay, but when you restrict here, it will be coming here. Okay, not only here, when you restrict it, everything you can make it as 1. When you do, okay, but it's not like this. You cannot make everything as many 1. Okay, so this is 1 and many 1, and you can see that they both are completely opposite. Okay, they both are completely opposite, right? And also you can note, see, in many one, okay, that is algebra, that is method. Come to method. When you notice this, okay, this 1 and many 1, it is actually a property. What property it is? It is a property of domain. Here also it is completely related to domain. Here also it is completely related to domain. But 1, see, here it is domain's property. 1 and many 1. Okay, this is the note point. Note this 1. Okay, note. That is 1 and many 1 is a property of domain. Is a property of domain. Okay, here it is, extremely sweaty. Next is, we are going to the next case, which is going to be onto and into. Okay. Then into. What is this onto and what is this into? They both are completely opposite, just like that. And one point that I have to say, this is also a note point. That note point is onto and into is a property of range. Okay, it's a property of range. So I think something has happened to the stylus. A, B, C, D. Okay, 1, 2, 3, 4. Here it is like this. When you are mapping it, okay, you have to map it like this. Okay. See, now you might have a question. Okay, now you might have a question. First that question is, can we map it like this? Okay, wait. Can we map it like this? A, B, C, D, E. Okay, is this allowed to map? Okay, so you might be hearing some noise from the AC. It's actually, so yeah, because I've turned on the AC, it's very hot. I cannot, it is blistering and boiling hot. Okay, So it is allowed it. Okay, there is no problem with it. Okay, there is no problem with it. Okay. So yeah, and here the condition. Okay, here you can see what condition I said. Okay, here you can see that. Okay, everything. Okay, only one pre-image. Okay, but here it is not like that. Okay, it's like more than one. You're shooting. Okay, you're shooting the balloon. You know, not the balloon game. Okay, here you see that one person is shooting one balloon, but here it is not like that. Here one person is here more than one person is actually at least more than in one case. In one case, at least more than one person is shooting one balloon. They are targeting one. Okay, so here you can see on to, so which means, okay, the condition for this is range okay, range should be always equal to codomain. Okay, always it should be equal here. Okay, that is why I said that this is property of what? It is property of range, because here you are dealing with this part. Here you are dealing with this part. So that is what. Okay, coming to onto, it is not like that. Here, A, A, B, C, D, E, F, G. Here you are going to take 1, 2, 3, 4, 5. Okay, so map it. Like this map, like this map, like this map, like this also you can map. Okay, but you are not supposed to map like this. Okay, this is not allowed, right? But this is allowed, right? Okay, here also it's okay. That is, see, here in this condition, range should not be equal to codomain. Here, range codomain. It should not be equal to codomain. Okay, and also note this one point. This is little bit, okay, this is little bit similar with 1 functions, but don't confuse. I got confused one time, but in that time I did not know that we can map like this. Okay, you can map like this. Okay, on to into function is like where you have interlinked. Okay, where you have interlinked many one function and one function. Okay, a little bit you have interlinked in sense what, in one function and in this function. No, wait. Here you might have a doubt. Here you might have a doubt. Many one function and into function are very same now. Not very same in sense, very similar to each other, right? Here the thing is A, B, C. Here the thing is, here you can leave if you want. Here you can leave like this also. Or you can also put here another element like A, B, C, D, E. Okay, so then you can map it and you can make it as domain is equal to range. It's your wish. Okay, it's your wish. So they both are not same. That you have to know. Okay. In some conditions they can be same. In some conditions they need not to be same. Okay, so we have completed one functions, then onto functions, then into functions, then all these we have completed. Okay, so with this heat itself we will also complete number of functions. Okay, I know still some other topics are there, but first we will complete number of functions. Okay, because now only everything will be in your brain very accurately. If I leave now and if I go to the proofs, like how to prove whether one is one function or whether one is onto function, and then you will forget this numbering. Okay, numbering should be done now even. We will do now even. Okay, so numbering. After completion of numbering, then we will come to the proof. Okay, proof also we have some methods of proof. NCERT method we have, then we have calculus method we have. Like this we have some methods. We will try with that also. But NCERT method is what allowed it to use in school. Calculus method is allowed it to use in your where in your competitive examinations. Okay. Case 1. See, for numbering, okay, you can separate it into some cases, that is, Hey, what? My handwriting is that bad, huh? Numbing is there. Okay, this is numbing even. Okay, for numbering, there is no R. If it is like a typing option, then it will be very good for me, but it is not like a typing option now. Okay, so now what you are going to do is, see, first case where n of a, what is a? A is actually always domain and b is actually always codomain. N of a is greater than n of b. Okay, then for the second case, okay, a you keep. I'll write in blue color. A is greater than B. Not good. This color thing. Then B is equal to A. Okay. Then A is less than B. Okay, A is equal to B. Then A is less than B. Why is this color not coming? A is less than B. We got. Okay, so you have got all these. First we will see the easiest step, then we will come to the tough, not tough at all, some tricky path. First is A is equal to B. Okay, so A is equal to B. Here this is what A, this is what domain, yeah, this is range, and then this is B. Okay. Okay. Now we will do with this one. Okay, this box in my head. So A is equal to B. See here A na number of elements in A and number of elements in B. So number of elements in A is equal to number of elements in B, which means number of elements in the domain is also equal to number of elements in codomain. This color is killing me. I will write 1, 2, 3 itself. Okay. So 1, 2, 3, 4. Then here it is A, B, C, D. See, both the elements are same. Okay. First is we are going to find the total number of possible functions. Total number of functions. Then total number of one function. Then what we have a total number of into functions. Then total number of main functions, then total number of, what is this, on into, sorry, on to then into functions. Okay, so first is total number of functions. Check here. One can be mapped, can be. Okay, it's not like one should be, can be mapped to A. Okay, one can be mapped to A, one can be mapped to B, one can be. It's not like one is going to be. Okay, C, one can be also mapped to D. Okay, one can be. For an example, okay, we will keep that one is being mapped to A for an example. Then 2 can be mapped to A also. There is no problem, right? This is allowed it. Okay, this is allowed it. But this is what not allowed it. Okay, this is what not allowed it. But this is allowed it. Okay, then 2 can be mapped to B, C, and then D. Okay, then for an example, we will take the 2 is also being mapped to A. Then 3 also same possibilities there. For 4 also same number of possibilities are what there. So that means, see, for 1 totally 4 possibilities are there, and then for 2 also there are totally 4 possibilities only. Because see, if this is being mapped, this also 2 can be also mapped to A. There is no problem with that. And also 2 can be mapped with B, 2 can be mapped with C, 2 can be mapped with D. And same applies to 3 also. 3 can be also mapped to A. There is no problem with that. 3 can be mapped to B. 3 can be mapped to C. Like that, you can map it as per your wish. Okay, this is allowed it. Like this, it is allowed it. But like this only, it is not allowed it. Note this one point. So if this 4 into 4 into 4. Okay, this 4 is for 1, this 4 is for 2, this 4 is for 3, this 4 is for 4 itself. Okay, like in case of formula, this raised to the power of this. Okay, that means number of elements in range raised to the power of number of elements in domain. So how many numbers? Okay, formula at last I will be saying to you all. Okay, formulas at last I will be saying. Now it's not required. Now over here, which is total number of 1 functions. So that means what? If 1 is being mapped to A, then 2 cannot be mapped to A. Then 2 is not allowed to be mapped to A. Then 2 should be mapped to B only. Okay. Then 3 should be mapped to C only. 4 should be mapped to D. Okay. So here it will be, for 1 there are totally 4 options. For 1 there are 4 options. But for 2 it has got reduced into what? It has got reduced into 3 options. Okay, then for 3 it has got reduced into 2, then for 4 it has got reduced into 1. Okay, so it is 4 factorial. Here it is what? Here it is 4 power 4. Okay, total number of many one functions. If you all have understood these two concepts very clearly, now then this is very easy. What is the formula? Total number of functions minus total number of one functions. Okay, so total number of functions minus total number of many one functions. Okay, one functions. Next is total number of onto functions. What's the formula? Okay, so the formula is, first is onto. What is onto? Onto is same as 1 right? Here onto is same as 1 na. So here it is also going to be 4 into 3 into 2 into 1. How it is same? See, wait, grouping is not here. Grouping and we will be discussing later. Correctly, 4 into 3 into 2 into 1 only, and here the formula is same only. See, here it is total number of functions, which is 4 power 4 minus 4 factorial. Here also it is just 4 factorial. Okay, here it is total number of functions minus onto functions. Okay, here it is total number of into function is equal to total number of functions minus total number of onto functions. Okay, total number of onto functions. So total number of functions total number of onto functions. Okay, now I will give you the formulas. 1 second. Okay, so the formula for total number of functions is actually b this raised to the power of this. So I'll write this in blue color itself. Okay, so then it will be b raised to the power of a. B is number of elements in range and a is number of elements in domain. Okay, next is total number of functions. One functions is going to be what? Factorial. What factorial? This factorial. So it is going to be a factorial. Total number of many one is actually b raised to the power of a minus a factorial. Okay. Next is onto functions. Okay, next is onto functions. So onto functions and into functions are very similar with name, so that please don't confuse its properties. Onto function is where codomain should be equal to range, and into function is where codomain should not be equal to range. Okay, so they both are completely opposite, but names are similar. Okay, so onto function is what? Here also it is going to be a factorial will be. Okay, here also it is going to be a factorial. The same formula, which is b factorial. Okay, b power a minus a factorial. And if you notice, in this case alone, okay, in where a is equal to b alone, these two formulas are same with these two formulas. Okay, so which means if you find this one function itself, it's enough. Okay, if you find this one function, then that's more than enough, where you will be able to find all other remaining three. Okay, all other remaining three. Okay, so first condition has got completed, and this is kind of easy. Okay, so next condition. This is also very easy, maybe. Okay, here it is. Next, what is next condition? Well, next we will take n of a is greater than n of b. Oh. Where is this? Okay. Next condition is that okay. So next condition is a here it should be greater, here it should be 1, 2, 3 and then 4. Okay, so here the shapes are not shapes, this one. Like this you cannot leave now. How will you leave? Okay, wait, first we will do, don't worry. Total number of functions. Okay, now see, a can be mapped to 1, a can be mapped to 2, a can be mapped to 3, a can be mapped to 4. Yes, right, there is no problem with that. Okay, so let us keep like a is being mapped to 1. Okay, next b can be mapped to 1, b can be mapped to 2, b can be mapped to 3, b can be mapped to 4 also. So there is no problem with that. Okay, also c can be mapped to 1, c can be mapped to 2, c can be mapped to 3, c can be mapped to 4. So there is no problem with that. This is also having all 4 options. Okay, next is see, d can be mapped to 1, d can be mapped to 2, d can be mapped to 3, d can be mapped to 4. So there is no problem with that. Okay, next is e can be mapped to 1, e can be mapped to 2, e can be mapped to 3 and e can be mapped to 4. There is also no problem with that. Okay, but note this one point, e can be mapped to 1 and e cannot be mapped to 2. At a time it cannot be mapped to 2 different elements from the codomain. Okay, from the codomain. This is what e domain. Codomain. Okay, so that means what are the total number of probabilities? Okay, total number of function is same. Okay, this raised to the power of this. So that means 4 raised to the power of 5. Yes, right? So 4 raised to the power of 5. Okay, next one is total number of 1 functions, then this one. Total number of 1 functions. Then what do we have? Total number of total number of 1 functions, total number of many 1 functions. Okay, total number of into functions, sorry, onto functions. Then total number of into functions. Okay, so first is total number of 1 functions. That means this should be mapped to 1. B can be mapped to 2. Okay, then C can be mapped to 3. Then D can be mapped to 4. But E is being left out. You cannot map P to any element from the codomain. Then it will become as many 1 function. Nah? So here it is not possible to map 1 functions. That means total number of 1 functions in this case is what? Is big mutai. Okay, is a big egg. Okay, next is many 1 functions. If you check the formula is same for here also. Total number of 1 functions minus total number of many 1 functions. Here if you, total number of functions minus total number of 1 functions for this one, okay, for this many 1 functions. But here total number of 1 function is 0, na? So then that means what? Here total number of functions minus 0. So that means here total number of many 1 function is equal to total number of function. Total number of many 1 function is equal to total number of functions. Functions is equal to total number of functions, which is 4 to the power of 5. Okay, this raised to the power of this. That means 4 raised to the power of 5. Okay. Next is total number of 1 functions. So what is this total number of 1 functions? Map it. This you have to map, 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 and this you have to map to like this. Okay. When you check it like this, here you have to do grouping. Okay, so grouping is here. This is the part where you have to pay a lot of attention. Okay, here you have to take this one. Okay, wait. You have to group these 5 elements into the group of 4. Okay, grouping is coming in the case of permutations and combinations. Now, their grouping you will be studying. So, which means you have to group these 5 elements in group of 4. Okay, so that is what the first case is. So for this little bit explanation is required. So there are totally 4 groups that you have to map. Okay, all these 5. Okay, so 5 elements are there. Okay, so 5 elements are there, which has to be mapped to the group of 4. So that means first 4 groups you have to put. Okay, 4 groups. So I can put here 2 elements. Here I can put 1, 1, 1. Okay, like this I can put. So this is the way. Okay, so you have mapped them now. So total weight here, which is first you have to put 5 factorial. Okay, total number of elements here in A, so that is going to be 5 factorial whole divided by C. 2 factorial you have to put. Okay, whole divided by 2 factorial. Okay. Whole divided by 2 factorial. Then 1 factorial, 1 factorial, 1 factorial. Then 1 factorial, 1 factorial, 1 factorial. Okay, so which which is, see, these three can be like shifted like this, like this at all, magic will be happening. Okay, so it is going to be 3 factorial here. Okay, and into, see, these four all can interswap within themselves, nah, within themselves they all can dance, they all can interswap, so into 4 factorial. Okay, see, here 1 is being swapped within itself. So 1 is in the denominator. 1 factorials are in denominator. So you have to put 3 factorial in the denominator only. And also 1 factorial is equal to 1 only. So you need not even mention 1 factorial. Okay. But when remaining some other elements like 7 is there, na, then and you have to group it into the group of 4. Na. So in that case, what will be happening? 7 elements are there here. For an example, here 7 elements, here 4 elements. Na. So here 7 in group of 4. Then you can put here 1, here you can put 1, here 2, 5, 3, 2 you can put. Okay, that is a way, like this it will be having some types, okay, some types in sense, like this some other similar methods will be there, but this is okay, this even we will go with, okay. So first is you have to write totally how many groups are, totally how many are there, 7 factorial is there, okay, whole divided by, what you have done, 2 factorial, 3 factorial, 1 factorial, 1 factorial, and since these two can interswap, so 2 factorial into 4 factorial. Like this, you have to write. Factorials are very important. Please don't confuse with these factorial. Okay. For an example, if 8 is there and you have to group in terms of 5, then what? Okay. So you take it as 1, 2, 3, 6, 7, and 8. So 1, 2, 3, 5. Okay. So 8 is there. So now how much? 8 factorial whole divided by, first is 1 factorial, 1 factorial, and 1 factorial. These one can interswap within themselves. So it will be totally 3 factorial. Then 2 factorial you have to put. Then 3 factorial you have to put. Then into what? Okay, this factorial you have done. This factorial, this factorial, this factorial. Then totally how many groups you have separated? 5 groups you have separated. So 5 factorial. Okay. So this is how you have to do. So next is total number of into functions, which is same formula, that is total number of functions, minus total number of onto functions. So their formula. Here see, it is same, b raised to the power of a. Okay, here for here, which is like I said again, for this what it is, here it is 0 only. So for here also it is b raised to the power of a only, this raised to the power of this. So for here what will be the formula? Here you have to do grouping. Okay, here what is this? b raised to the power of a minus grouping. Okay, grouping is the place where it is a little bit tricky. Then what is there? We have, I think after uploading this video for about many days I will not upload, because this video is taking me forever to take. Next is what? N of a is less than n of b. Okay, so now we have come to greater than. Okay, so now we have come to greater than. Here you can check that 1, 2, 3, 4, A, B, C, D, and then E you have. So this is domain, this is codomain. So how it is going to be? First is total number of functions, right? Total number of functions. Okay, so now total number of functions. First this one you map. Like this you can map like this, like this, like this, like this, like this. So as I said that this raised to the power of that, so this raised to the power of this. Okay, so which is going to be, what are they? 1, 2, 3, 4, 5. Okay, 5 raised to the power of 4. So which is the same formula, which is b to the power of a. Okay, b to the power of a. This is the same formula. Okay, so b to the power of a. Next is total number of 1 functions. One, many one. Okay, on to then the into. Okay, so first is total number of 1 functions. What are they? How can you map? You can map like this. You can map like this. Right. Once again. Okay. Then you can map like this. Okay. This is elaborate. One element can be left in the case of code. I mean, that's okay. That's perfect. We have no problem with that. So here, what is this? Okay, so what formula will be getting? 4 into same factorial only will be getting, na? Yeah. So here, what will you be getting? You'll be getting which color? This color only. See, 1 has 5 options. Okay, so 1 has 5 options. Then 2 has how many options? Only 2 has 4 options, then 3 options, then 2 options. So yeah. Okay, within 2 itself it has got completed. Next is total number of minimal functions, which is same formula only, total number of functions. Okay, so total number of function is b to the power of a minus. So what formula will you say for this? So for total number of 1 functions, what is the formula? For this, what you have to do is b to the combination of a into a factorial, which means from b you have taken elements which are in the count of this one. See, what is this formula? B factorial whole divided by a factorial into b minus a the whole factorial. Okay, this is what the formula now. So this into a factorial again you have to do, then you will be getting this value. Okay, then you will be getting these values. Okay, or permutations. Okay, this is even enough. If they have given you the number, then these formula also you need not to apply. Just for an example, if they have given here as totally 5 elements and here they have given here totally 4 elements, now 7 elements, and then what will be doing? Then 5 into, 7 into, 7 into 6 into 5 into 4 into 3. That's it, completed, just like that. Okay, just reduce it till 5 times. Okay, reduce it till 5 times. 7 you reduce it till 5 times. Okay, so here it will be B CA into A factorial. Okay, into A factorial, which is equal to permutations only. Which is equal to permutations. Okay, so PBA. I will check one thing. Okay, so yeah, this is correct. Okay, so this is correct. So which is equal to BPA. Okay, which is equal to BPA. Okay, so next is onto functions. No matter what you do, you cannot make onto functions. Okay, to make onto functions, then you have to map this also to this. That is not at all possible in case of functions. So here this time, this is egg. This is egg. Okay. How many of you guys see Augie and the Cockroach? Once upon a time, now I won't, but I see Tom and Jerry. Okay, so next is this one. This color is okay. Into function, which is equal to total number of what? Here for this formula 0. For this is equal to total number of functions. So here for this formula is going to be b to the power of a. So here it is going to be 5 to the power of 4. Okay. Here one function curve. What you will be getting? You will be getting 5. Wait. 5 to the power of 4 minus 5 into 4 into 3 into 2 into 1, which is equal to 120. I don't know what is 5 to the power of 4. That you have to calculate. Okay. So with this, that we have completed. Now we are going to enter into the concept of proofs. Okay. So what proof is? My legs are paining. But if I go down, then I have to give them the phone. Then I cannot take video. Okay. So proof first is one functions and then many functions. Okay. Now they might give you a function. Okay. So they might give you a function, and then they might ask you, prove this, whether it's this one function or whether it is onto functions. For this, what you have to do is, I will say to you, okay. So first is, okay, these many if we take none, then it will be kind of confusing. I will take any one element, 2 elements, then 3 elements we will take here. Okay, so first is one functions and onto functions. How will you prove? See, first I'll write the sentence, then it will be kind of clear. Function that tends a to b, okay, is many one if there is at least two elements like x1 comma x2 that belongs to the domain A, okay, such that f of x1 is equal to f of x2, okay, f of x2 then f of x1, okay, comma f of x2 in B, but x1 is not equal to x2. This is one condition, that is one condition. Okay, so first remember that if a function can be either 1 1 or many 1. It cannot be both 1 1 and both many 1. Okay, so now how will you prove this? Very simple. First, what you are going to do is, okay, I will take two different elements here and here. See, before proving this, what you will be assuming is, you will be assuming that this function is minimal function. Okay, whether they are given or not, you will be assuming that this function is actually minimal function. This is the NCRT method. Then you will be going to the calculus method. Okay, so first you will be assuming whether this is actually you will be assuming this is actually minimal function. Okay, so this will be giving you f of x1. Okay, then this will be giving you f of x2. Okay, and you will be equating these two. Okay, then you will be equating these two. If in case these two has become the same, okay, see, then you will be equating these two, which means already I have assumed that this is many one function, so that means this and this is equal. Okay, so this and this is equal. Note my point. You have just now said that this is actually many one function. You have just now said that this is many one function. That means this, and I have assumed x1 and x2. These two are giving you the same output. So which means f of x1 is equal to f of x2. This is what I am trying to say. Okay, so then it is many one function. Okay, many one function. Infinite is what I have done for writing many one. Okay, many. Now what you'll be doing is you will be equating this one and you will be equating this one, and if you get x1 is equal to x2, okay, if you get at last x1 is equal to x2, that means this also has become same. So this is same and this is also same. These two are same. So that means what? This is 1 1 function. When you get like this is 1 1 function. And if you have not got, if you don't get like x1 is not, if you get it like this, okay, if you get it like this, then it is many one function. Then it is many one function. I repeat myself, this is actually many one function. Okay, you have assumed it to be a many one function. You can assume anything. Okay, you can assume anything, and you have assumed it to be many one function. So now that means what? F of x1 is equal to f of x2. So now it has become as 1 point. So this is actually a single output. Okay, f of x1 is equal to f of x2. So then this will be x1, this will be x2. So this has become a single output. So then that means you can map it like this. Okay, now this is many one function. Now what you are doing is you are equating this. Okay, there will be an equation. You will be equating it. At last you are getting x1 is equal to x2. That means it will be x1 is equal to x2. So then the mapping also will be like this, a single line. So which makes it as many one function. Okay, this is what I'm trying to say. I hope it is all clear. Don't worry, one sum you will be doing. One sum. Okay, this is the NCRT method. Here is some. So they have given you f of x is equal to 3x plus 5. Okay, 3x plus 5. Okay, this is what. So now what you have to do? You have to assume x1 and x2. You have to take x1 comma x2 belongs to where? Okay, no. Okay, x1 and x2 are elements of A, which is the domain. Okay, so then coming into here, how will you take? First is f of x1. Okay, first is f of x1, which is equal to 3x1 plus 5. Okay, f of x1 which is equal to 3x1 plus 5. Then f of x2 you have to take. Okay, which is 3x2 plus 5 is what you have taken. Okay, now what did I say? These two are equal, I said, right? You have already assumed that. So that means equate these two. So here will be 3x1 plus 5 is equal to 3x2 plus 5. Okay, so 5 terminate. Okay, 3 cancel. So at last what did you get? x1 is equal to x2 you got. Okay, so x1 is equal to x2. you have got, so which makes this domain as same and output is also same. So that means this 1 function, 1 function. Okay. Next, one more sum we will do, and this is the NCERT method, as I said, not the calculus method. Calculus method is actually kind of easy, but the thing is, you want to know this derivative, okay, derivative, and also one more method is there. Totally 3 methods we will be discussing, okay, so that it will be very easy for you all to note. Okay, so here it is, f of x is equal to x square. So same thing you are going to assume. You are going to assume that x1 and x2 belongs to the domain. Okay, and then same thing you are going to take, which is f of x1 and then f of x2 you are going to take, and then you are going to write it. So then it will be x1 square, which is equal to here x2 square. Okay, here it is going to be is equal to x2 square. Okay, now we equate them. So f of x1 is equal to okay, so f of x1 is equal to f of x2, which is equal to x1 square is equal to x2 square. Okay, when it is like this, when you are having a square is equal to b square, then you can write as a is equal to b. Okay, like that you can write. So which means x1 is equal to x2, and also you can write it like this, where a plus b is equal to 0. Like this also you can get, because when it is a square is equal to b square, it will be a is equal to minus b. Like this you can get, or plus or minus b. Okay, a is equal to plus or minus b, you will be getting when it is plus b. Okay, a is equal to plus or minus b, you will be getting now. Okay, so a is equal to plus or minus b. So take plus b, a is equal to b, that is what I have written here. And when is equal to a is equal to minus b, then it will be a plus b is equal to 0. So x1 plus x2 is equal to 0. Okay, like this also you can get. See, when you are getting like this two conditions, now then it is not many one functions, it is many one function. Okay, so here it is 1 here it is many one. Horizontal line test. Vertical line test is to test a function. Horizontal line test is to do what? Okay, so horizontal line test is to check whether a function is 1 or not. Okay, so how will you check? Okay, so can you all remember these two graphs? Comment in the comment section. I will say this is A and this is B. Okay, what graph is graph A and what graph is graph B? Comment in the comment section. Okay, one clue I will give. It can be either exponential, exponential, or it can be either logarithmic. Okay, so horizontal line test in sense, you have to draw an horizontal line. Okay, so you have to draw an horizontal line, and then you have to check. Okay, and then you have to check. Draw a horizontal line, and then check if it is being intersected only at one point. Now then okay, then it is one function. But if it is being intersected at more than one point like this, then it is not an one function. See, here it is being intersected only at one point, so it is a one function and one function. Here it is not and one function. Here it is many one function. Okay, because see, when you give, okay, when you give an input, you are getting only one output, okay, only one output. But here it is not like that. Here it is not like that. For one, see, for here one input is there, here one input is there, okay, and for both of those input, what you're getting the same output only. So for an example, if I keep this as x1 and if I keep this as x2, so x1 and x2 you are getting, and if I'm keeping this as y1, so see, for x2 also you're getting y1 and x2 also x1 also you're getting y1 only. So see, it is what? It is minimum graph. It is minimum graph. And here for this we'll be getting, like, if this is x1 and if this is y1, then the graph will be like this. Okay. After this, coming to the calculus method. For this, you have to know some amount of calculus, but don't worry. For that also, I will be uploading videos. Till then, you have to wait and watch. Okay, till then you have to wait. Or else there are many videos in YouTube also. You can go and learn them. But calculus is where just the differentiation that you would have learned in 11th standard. For an example, cos x is turned into minus sin x is turned into plus cos x, like that. Okay, it is like x square is turned into just 2x. Okay, it is turned into 2x, like that it is. Okay, so I'm very hungry. I did not eat breakfast and now it's around 1. So it's 12. Oh. Calculus method. So with this calculus method and then with that inverse function, we will be completing the video thoroughly. Okay, I will try to attach to this video also rational function also. Okay, but till 15 minutes this video will be taking. Okay, till 15 minutes this video will be taking. So what is this calculus method? This is actually a shortcut thing which you all should know. Okay, for an example, in applications of derivatives, I will be saying this to you. Okay, not in the continuity and differentiability, that it will not be coming. In applications of derivatives, in part 1 or in part 2, I will be saying. You might ask me for inverse trigonometry, which is a small lesson. For that, I have put those many parts. For continuity and differentiability, I have put those many parts. But why relations and functions are in one short video? See, it is because relations and functions is very important lesson. Without this lesson, learning other lessons are kind of tough. Okay, learning other lessons are kind of tough. This lesson's basic should be within your hand. Then only we will be able to learn other. I'm not like, for me also this lesson is kind of, after see how big this lesson is, it is kind of thinking for me, okay, how am I going to learn all these? But once you have understood, then everything is very easy. Okay, see, first is calculus method, where this is actually decreasing or increasing. Okay, decreasing or increasing. That means they would have given you a function. Okay, they would have given you a function. Okay, a function would have been provided to you. Okay, you have to differentiate this function. Okay, so the differentiation, instead of writing like this, I can write it also like this. Okay, this is a notation. So when you differentiate it, if this differentiation is greater than 0, or actually this differentiation should be increasing, and also there is graphical method. Okay, also by using graphical method is what this horizontal test is. Okay, then this one is also kind of similar to graphical method, and then this is actually a calculus method. Okay, see, this is increasing now. Okay, so this differentiation is actually increasing, which means it's greater than 0, which means, and then if it is decreasing, which means it's less than 0. Then if it is both increasing and decreasing. Okay, both increasing and decreasing. Increasing, decreasing. Okay, then both increasing and decreasing. That means neither increasing nor decreasing. Like this it is. Okay, so x1, x2. You are going to take one time interval. x1, x2, x1, x2. Okay, so now let me name this case as case 1, this is case 2, case 3. Okay, so first this case 1, that is what I'm going to draw here, case 2 is what I'm going to draw here, case 3 is what I'm going to draw here. Okay, so first this, if it is increasing, and then the graph will be like this. It need not be a perfectly straight line, it can be little bit. Okay, then if it is decreasing now, hey, it should be a perfectly straight line. Okay, then decreasing, and then like this it is. Okay, like this it is. And both increasing and decreasing in sense, then like this it will be. Okay, now do horizontal line test. Okay, now do a horizontal line test. Okay, perfect. Wait. Okay, it can be like this. Okay, then also like this. No, wait. Okay, like this. Now do a horizontal line test. Which color? This color. Okay. So horizontal line test, horizontal line test, horizontal line test. See, only one point is being intersected, so this is 1 1 function. Here also it is 1 1 function, but here it is not 1 1 function. So that means for these two cases, it will be definitely 1 1 function. Okay, but for this case, this is not going to be 1 1 function. Okay. Next is inverse function, even function, odd function, equality function. Okay, it's, yeah, it is increasing. Just now they came to my brain. Okay, so periodicity is also there, but those all are JEE concepts, and I'm not JEE student. Okay. Actually, here is the place which is very problematic. This is the place where it is very problematic. But this place, okay, other than this, these two places are okay. And I will not say now even to use all these things, yes, okay, like because if you are after learning the applications of derivatives, then we will use this one. Okay. So before that, I have to say names. Okay, some other names are also there that you all have to know. See, 1 1 function, then onto function, okay, then bijective function. So these have other names also. 1 1 function is also known as injective. Okay, this is known as surjective. When it is both 1 1, okay, and it is this onto. Okay, when it is like this, then it is known as bijective. Or also when it is both the injective and the surjective, then this is known as bijective. Okay. Next is, actually when I was taking notes, I was in a hotel. Okay. Okay, equal or identical function. See, to be equal or identical function, there are some conditions. first condition is that that domain, see, equal or identical function. Now you are taking two different functions and you are checking whether those two functions are equal or not. See, in that case, domain of that function, domain of one function f of x1 should be equal to domain of another function, domain of f of x2. You have taken one function and you have taken another function, then you are equating them. That means you are checking their domain. If their domain is same, then if their range is same, if their range of f of x1 is equal to range of, if their range is also same, range of f of x2 is same, then if their graph overlaps exactly, then it is known as equal or identical function. When all these three cases are followed, when domain is same, when range is same, and their graph is also exactly identical, then you can see that they are equal and identical function. Even function or odd function will come later. Even function and odd function. Even function now, even function. So what is this even function? No matter what input you give. For an example, you are giving f of x minus x, now then it should be giving you plus x only. See, it should be same. You are giving an input, or for a function you are giving an input, and that input is actually minus x. It is a minus number. And the output is actually same. These two outputs are same. Even when you are giving here f of plus x, also it should be giving here f of plus x only. Best example is cos theta. Best example is cos theta. How will you find it based on the graph? There is one method to find it based on the graph. Like this it is now. See, now when you put like this, when you turn this dosa like this, example, you are having a dosa, and when you're flipping it now, like this, if you're flipping it now, then those two should be exactly overlapping. Those two should be identical to this one. Wait. So how can I flip this? Like this I can flip, huh? Okay, wait. Then flip it. See, those two should be same. Actually, my diagram is that much inaccurate. What can I do? But those two should be exactly overlapping. When you are taking this dosa, when you are folding this like this, those two should be exactly same. Like this. This is what even function is. Coming to odd function. If f of minus x is there, then it should be giving you minus f of x. Minus f of x. If you are giving f of plus x now, then it should be giving you f of x. I know this one and this one does not make any sense, but for understanding I said. For an example, take that you are having a straight line. Okay, a line like this. Okay, this time you are not supposed to fold it like this. Don't fold it like that. Okay, this time fold it like this. Okay, like this, or you can fold it like this. Okay, when you are folding like that. This is first quadrant. Okay, so this is first quadrant, this is second quadrant, this is third quadrant, this is fourth quadrant. When you are folding, you have to make sure that 1 is overlapping on 3. Okay, when 1 and 3 are exactly same, the graph is same, then it is odd function. 1 and 3 or 2 and 4. Okay, when these two are exactly same, okay, like this when they are same, and then also, okay, it is odd function. Okay, now coming to inverse functions. So there are totally, see, 2 different steps are there. Okay, for an inverse function, how many steps are there? 2 different steps are what there. 1 second. Okay, so there is actually one thing. Also, composite function is there, but there is no way that I'm going to. Okay, wait, I will say some. First is we will do with this itself. Okay, inverse function. Okay, so inverse function is where only one condition is there. Okay, that is it should be bijective. That means it should be both injective and surjective, or it should be both 1 and on 2. Okay, then 2 different steps are there. First is make in terms of y, for in terms of x, then substitute x with y. Okay, for an example, I've got an example like this. Okay, where f of x is equal to x cube. Okay, so this is the example that I've got. So how will you do this? First, you have to know that y is equal to x cube. What did I say? Right, in terms of x, that means x is equal to y inverse. Okay, x is equal to y inverse of cube. Okay, so this is what you have got. Next is what? Substitute x with y. So already in inverse trigonometry also I said, okay, some basic introduction I have given, but from this point only we have taken. Okay, this one I did not say. Next is y is equal to x inverse. Okay, y is equal to x of 1 by 3. So here f inverse of x is equal to x. So this is what inverse. Inverse of this is what? This is. Okay, inverse of this function is this function. Okay, so we will do another example. Y is equal to 2x plus 3 whole divided by 4. For this, first make in terms of x. So 4y minus 3 by 2 is equal to x. Yes, right? So 4y minus 3, I don't know, I just by looking I said, correct. Okay, so now substitute. Okay, this is what step 1 is. Substitute x with y, so that means 4x minus 3 by 2 is equal to y. So then the inverse of this is going to be, inverse is equal to This is what the inverse now. So then inverse of x is equal to 4x minus 3 whole divided by 2. Okay, this has got swapped and here sign has got changed. Okay, so then after that, that's it. Okay, composite functions you are having. So what is the composite function? Actually, composite na, you take bread. Okay, you take bread as a function and you take omelette as a function. Okay, so you are keeping one function inside another function. So you are keeping omelette inside bread. So that is what actually a composite function is. So it is represented like this: f of g of x. Okay, so f of g of x is one thing, then g of f of x is also another thing. It is like keeping a function inside a function. That is what it is. Okay, like bread, and inside that bread you are keeping an omelette, then another bread. Ta-da. Okay, for an example, let us take it like this. Okay, f of x is equal to sin log x. Okay, log x. Then g of x is equal to sin x. Okay, then this is not good handwriting. It's okay, I don't care, I'm hungry. எனக்கு சோறு தான் முக்கியம். Okay, so first this we will do for this one. So f of g of x. So what is f? F is log, so it's equal to log. Okay, log f is what? First write what is f of x. F of x is log x. Okay, and actually this is what x is. Okay, here this is what x is. Okay, so x is equal to what? G of x. Okay, so x is equal to what? G of x. Okay, so in place of this x, in place of this log x, in place of the x, I'm going to write g of x, which is equal to sin x. Okay, then what is this is known as, this terminology can be also written as f of g. Fog. Okay, what happened? Fog happened. Okay, next is g of x. G of f of x is equal to, what is g? G is what? Sin x. Okay, so g of x is what? Sin x. Okay, so what is x here? X is what here? F of x. What is f of x? F of x is log x. So in place of x you have to put log x. Here you can check, this is an input. Okay, this is an input, and after, when this input is being when this sign is using this input, then it will be converted as an output for g of x. Okay, for g of x this will be converted as an output. Okay, but for this log, okay, for this f of x, this total term is the input. Okay, same for this, we will do one sum. Okay, then with that one sum we will be ending this total video itself. I have no idea, but I'm sure that it will be around 3.5 hours or something like that. But I'm taking this for 3 days. Okay, 3 days I'm taking this. I'm trying to take this video, but I cannot complete it. Okay, one second. I'll get the sum. Okay, so I've got these two questions. X plus 1, f of x is equal to x plus 1, and f of g of x is equal to x plus 2. Okay, this is x. Okay. So, what will you do? I will find f of g, you all find the g of x. Okay, so f of g of x. Okay, and this is what I'm going to find. For I'm going to find. You can find. Okay, we will find both. I'll find both and I'll end this video happily. Okay, so first, what is f of x? First, this is what out now. So first, what is f of x is equal to x plus 1. Okay, for f of x, x is the input, so you have written here x. But for f of g of x, here what is the input? Here g of x is the input. So in place of x, you have to put g of x. Okay, so you have to put g of x. Okay, what is g of x? G of x is x plus 2 now. So it is going to be x plus 2 plus 1, which is equal to x plus 3. Okay, then what is g of f of x? First, what is g of x? G of x is x plus 2. Okay, same here for g of x, x is the input, so you have put here x. Okay, but for g of f of x, okay, here f of x is the input, so in place of x you have to put f of x. Okay, what is f of x? F of x is x plus 1, which is equal to x plus 3. Okay, see, both are same, but not always they'll be same. It is pure coincidence. It is a pure coincidence. Okay, but sometimes it can be same, sometimes it will not be same. It's something that you are going to take. Okay, I hope all these are clear. We have done plenty of examples, plenty of sums, everything we have done. Okay, so with this we will be ending in this video. Till then, till we meet in another video. Bye bye.